Alright, here's the second part of today's video. So we're trying to find the distance between 2 points. So we've got our distance formula, which is we subtract the x values and then square them, and then we add and then plus, we subtract the y values and then square them, and then we add and then we subtract the z values from each other and square them. Okay, so there's our formula for finding the distance between 2 points in a 3D plane. Okay, so we've got this box, and we know the coordinates are 2, 3, 4. Okay, so for point A. So I've gone out in the x direction to, so I'm just going to write these coordinates here so we know what they are. So at R, we've gone out in the x direction, we've gone 2, but in the y direction we've gone 0, and in the z direction we've gone 0 because it hasn't shifted up. So we've just only gone in the x direction 2. To C, we've only gone in the y direction, so this is 0, something, 0. We've only gone in the y direction, and in the y direction we've gone 3. Okay, and then point F, we've only gone in the z direction, so for point F it's 0, 0, and then we go 4. Okay, so R, we've got that one. R equals 2, 0, 0. C, we know is 0, 3, 0. And B is the same as C, except it's shifted up 4. So at B, we're at 0, 3, and we've shifted up 4. So B is 0, 3, 4. And Q. Q is the same as R, except it's shifted up 4. So Q is 2, 0, 4. So like I said, Q is the same as R, except it's been shifted up 4. Okay, so question B. Find the maximum length of the garden tool that can fit in the storage box. So to figure out the length, we're going to have to figure the measurement or the distance from O to A, right? So because it's the diagonal across the thing. So we know that O is 0, 0, 0. So from O to A, if we're following this formula here, since O is 0, 0, 0, we're just going to have x squared plus y squared plus z squared, and these x1, y1, z1 is 0, 0, 0. So let's do this. So we've got so 2 minus 0 squared plus 3 minus 0 squared plus 4 minus 0 squared, which gives me 2 squared plus 3 squared plus 4 squared, which gives me 4 plus 9 plus 16. And that equals the square root of 29, which is approximately equal to 5.39 meters. And that's the length from O to A, the diagonal. Now, question C is a little tricky. Question C says, C is not the tricky one. Find the height of RQ. So the height from R to Q is, all it is 4 meters. Okay, so RQ Q height is 4 meters. All right. Okay, and then question D. What is the angle between diagonals BR and BQ? So B to R is the diagonal from this corner to the far corner, and BQ is from here to Q. So I'm going to draw this triangle. Okay. So we've got R to B and B to Q. We know this red line here, QR, we just said that that's 4, right? And R to B is the same as O to A. It's the diagonal across. And so this diagonal across, we just figured out in part B, because it goes from the farthest corner to the other corner, we just figured out is 5.39. Okay, and we're trying to find the angle between BR and BQ. So I'm just going to put an alpha there. Okay. So we're trying to find alpha. So to figure out this angle, here we've got the opposite side, here we've got the hypotenuse, and if I've got the opposite and hypotenuse, let's think SOHCAHTOA. So if I've got the opposite and the hypotenuse, I'm going to be using sine on a right triangle, because this is a right triangle because each corner of a cube they're all right angles, right? Okay, so I'm going to say sine of alpha equals opposite of hypotenuse, so 4 over 5.39, and I put that into my calculator, and I get sine of alpha equals 0.7428. And then I do my inverse sine, so I put that into my calculator, and then I get that alpha is equal to 47.97 something else, so that's going to be approximately 48.0 degrees. Okay, you might want to hit pause and think about this, maybe replay, and let's continue on. Okay, so find the distance between each pair of points. So I've got my x values and the y values. So my x values is 4 and negative 1.5. So I subtract them. 4 minus negative 1.5. So minus negative, that's going to be positive. We have 5.5 squared. Negative 3 minus 5 is going to give me negative 8 squared. So negative 8 squared is 64, and 5.5 squared is a number, and add that to 64, and we get 94.25, and take the square root of that, we get this. Okay, so here we got 1 minus negative 4 is going to give me negative 5. Negative 2 minus 0 is going to give me negative 2 squared. And 10 minus 3 is going to give me 7. We're going to square all those. And why did I write squared after we square that? That was silly of me. Okay, so 5 squared is 25, 2 squared is 4, 7 squared is 49. And of course, when we square negative numbers, they become positive. Add these together, you get 78. Take the square root, we get this. Okay, let's look at question 2. The distance between two towns is 2 kilometers, and the coordinates are x, 7 and 3, 5. So here we go. Here's our square root formula. We know that the distance is 2. The difference from our x values is going to be x minus 3, right? The distance of the y value, the difference of the y values is 7 minus 5, right? Okay, so x minus 3 squared, we just leave that the same. 7 minus 5 we know is 2. And if I square both sides, the square root's going to go away. And then we square 2, we're going to get 4. Okay? So 2 squared is 4, right? We subtract 4 on both sides, we're going to get 0. X minus 3 squared is equal to 0. We take the square root of both sides, we get x minus 3 is 0. We get x is 3. Might want to hit pause and think about this. Let's look at number 4. Okay, we've got a formula for a circular shape. The diameter of the circle has endpoints at 1, 7 and 0 and negative 2, 1. Find the circumference of the fountain. I'll draw a picture. You don't really need to, but 1, 7, 2, 3, 4, 5, 6, 7. There's point 8, A, and negative 2, 1. Okay. So we got a circle. All right. So the first thing we need to do, in order to figure out the circumference is 2 pi r. So we need the radius. So in order to figure the radius, I'm going to use the distance formula. So we subtract the x values from each other. 1 minus negative 2. 1 minus negative 2 is going to give me 3. So we got 3 squared. Subtract the y values. 7 minus 1 is going to give me 6. So we've got 3 squared plus 6 squared. 9 plus 36. Square root of 45. And we get our diameter is 6.71. Okay. So that means the radius is half of that. So the radius is this divided by 2. Okay. So we got this radius of this, and then times 2. Well, of course, so the circumference is really pi times the diameter, right? So our diameter is 6.71, so 6.71 times pi. Here is our circumference. You might want to hit pause and think about this. Okay, let's look at number 5. Okay, here we've got a kite, and it's a parallelogram, and we've got the diagonals that intersect at the points, and the points I've labeled them. Find the values of x and y. So the first thing I did was I said, okay, well, we've got 3, 6, I labeled that. We've got 1, 3, I labeled that. And we know that this is x, 6, because in the y direction, it's still the same height. So that's why the y values stay the same if I go this way. And if I went over here, the y values stay the same. So we know that this is going to be 3 also. We don't know this value here yet. So if I want to find what x is, well, we know the midpoint is 4, and we know that the x value on this end and the x value at this end is 1 and x. So we take the average of 1 plus x over 2, and that's going to give me 4. So if I know 1 plus x over 2 gives me 4, we can multiply both sides by 2, and I get 1 plus x equals 8. And then so I subtract 1 on both sides, and I get x equals 7. Okay, now let's try to figure out y. Well, we know that the average of between 6 and 3 is going to give me y. So 6 plus 3 divided by 2 is going to give me y, because y is in the middle, halfway between the 6 and the 3. So 6 plus 3 is 9, and 9 divided by 2 is going to give me 4.5. Okay, let's look at the last question here. We've got a tracking station that lies at the origin, and the coordinates are in the x and y axis. X is due east, the y-axis is due north, and the z is vertically upwards. Two aircraft have coordinates of 20, 25, 11, and 26, 31, 12 to the tracking station. All the coordinates are in kilometers. Find the distance between the two aircraft. So I'm going to take my x values, y values, and z values, subtract them from each other, and square them. So 26 minus 20 is going to give me 6. 31 minus 25 is going to give me 6. And 12 minus 11, that's going to give me 1. We square each of those. So 36 plus 36 plus 1 gives me 73. Square root of 73 is going to give me this. Okay, question B says, the radar at the tracking station has a range of 40 kilometers. Determine whether you'll be able to detect both aircraft. So we need to figure out the distance from the tracking station to each plane. And the tracking station is at the origin. The origin, by definition, is always 0, 0, 0. Okay? So, to figure out the distance between aircraft A and the origin, well, these subtraction values are going to be 0. So I just do 20 squared plus 25 squared plus 11 squared. And we do the calculations, and we get this distance is 33.8, and this distance is 42.2. And it said that for the radar to work, it had to be a range of 40 kilometers. So this one is too far away, so the radar will detect the first aircraft, the 33.8 kilometer aircraft, but it's not going to detect the second one, which is more than 40 kilometers away. Hope that helps.